So we are going to discuss about carbon polar bond making. Right? Actually, this section is more easier than the carbon-carbon bond makings. Right? Than the carbon compared to the carbon-carbon bond makings. This will be very easy, lamai. If you are okay with the carbon-carbon bond making techniques, right? This is very, very easy. Right? Let's discuss this stuff then. Right? This is all about carbon polar bond makings. So here this is actually at your page number 11 of your tute, and here actually we are supposed to learn about 5 kinds of carbon polar bonds, right? Making of 5 kinds of carbon polar bonds we are about to study now, right? What are the 5 kinds? Let's discuss. The 5 kinds are, right, making the carbon nitrogen single bond, which is known as the amine bond. First we'll discuss about this. Then, right, we'll discuss about forming the carbon nitrogen this bond, this one, right, this one. This is referred to as the amide bond. Amide bond. Right. These are amides, no? We know the stuff, no? R, C, O, N, the stuff. That's how many ROHs, no? Amides, no? So amide bond. Then we'll learn about how to make the carbon nitrogen double bond. Carbon nitrogen double bond. How to make this one? This is referred to as the imine bond or imine bond. These are the 5 types of bonds we are going to learn, right? We are going to make here at this topic, right? The 4th one, then we'll discuss the formation of carbon oxygen single bond, like carbon nitrogen single bond, the carbon oxygen single bond. This is referred to as the ether bond. Ether bond makings. And finally, we'll discuss about the ester bond. Ester bond. This one. Right? These 5 bond makings are going to be discussed under this section. Ester bond. Right? These are the 5 things. Right? We are supposed to discuss here. Right? Okay. Let's discuss one by one. Starting with the amine bond. Right? Amine name, but I'm going to dig around. Right? Okay. See. I'll first introduce the theory. Right? Then first I'll first introduce theory, and then one of the one example conversion. Right? Quickly we'll go through the 5 bonds. Right? So first thing is about making the CN is known as amine bond. Amine bond, right? So basically, amine bonds are made actually by reacting alkyl halides alkyl halides, reacting alkyl halides with amines, Normally it could be primary or secondary amines. Let's discuss. This is the theory part of the CN bond making. It's like this, Lamai. Say you are with this alkyl halide. Right? If you react this alkyl halide with this kind of amine, see, if you react this alkyl halide with this amine, I'll take some R group here, simply some R group here with this amine. And if you react this alkyl halide with this primary amine, only one R group is there. No? Those are known as primary amines. No? If two R groups are there, secondary amines. Three R groups are there, tertiary amines. Like the carbocations, no? Number of R groups, right? Okay. So what will happen is actually this small HBr bond, some HBr molecule will release, and this nitrogen will connect with this carbon. This nitrogen leaves its one of the hydrogen bonds, one of the bonds with hydrogens, and this carbon leaves its one of the bonds with bromine. Just one bond is there, that bromine will be left, right? So these two guys will connect, right? Forming the amide bond. See, CH3, CH2. This is actually a bond made between the carbon and nitrogen, right? One hydrogen is there and the R is there, and the HBr molecule will be left, right? So you can use secondary amines as well, not only primary amines, but also secondary amines. Secondary amines means these nitrogens with two R groups. Still, as you are with hydrogen here with the nitrogen, so that hydrogen will leave with this Br, connecting the two atoms, the carbon and nitrogen, right? That is what happens. So again, some alkyl halide reacting with secondary amine, right? See the compound CH3, CH2, R1 and R2, and small HBr molecule will be left, right? HBr molecule will leave, right? Okay. So that is the idea. That is how you are supposed to form the CN single bond. Right? So if you examine this final compound in conversion, that is what we need, no? If you examine this final compound and try to predict what compounds reacted to give this one, so that prediction could be done like this. Just take the CN bond, that is from where you have to break the larger compound and put some hydrogen to the nitrogen side and put some Br to the carbon side. So as this is a polar bond, CN is kind of a polar bond. In your smaller polar molecule, right? To the negative pole of the bond, to the negative pole of the CN bond, put the positive pole, the hydrogen of the HBr to the positive pole of the CN bond, put the negative pole of the HBr. That is how you are supposed to come up with the two reacted compounds, so that you will come up with the two reacted compounds, initial compounds, R1R2NH and CH2CH2Br. Right? That is how you are supposed to think backwards to use these reactions in a conversion. See, if you break this one, final compound from here, from the polar bond, if you break the final compound from polar bond and put the hydrogen to the nitrogen side and put the Br to the carbon side, you will come up with the two initial compounds which are responsible for the formation of this larger compound. See, CH3CH2Br and the H in NH2R, RNH2. Right now? So these are amines, and this is the amine bond. This is the amine bond, and these are referred to as amines. The amine bond referred to as amines. Right? So this is the theory behind the CN bond formation. Right? Okay. Let's use this knowledge which we have gathered for a conversion. For a conversion, let's use this knowledge. Right? I'll explain you an example conversion here. Right? So these things are there in note at the page number 11. The note is there. So if you need, you can highlight this molecule, highlight these ones, and you can mark this breaking. So that's how we think, right? So you can mark the stuff which I have written in red color in your page number 11, right? Okay, so just take a screen capture, then you can complete the note now. Right. Let's try to synthesize a compound, right, with the use of this technique. Right. See, I'll come up with this compound, right? So as example compound, right? The example conversion. Lamai, I have given you some spaces at the page number 13 and 14. At the page number 13 and 14, you have some space, right? So there, you can write these example conversions. You can complete those notes of example conversions at the page number 13 and 14. You can write those things, right? So this is our example conversion, right, for the amine bond. So you are supposed to start with CH3CH double bond CH2, and let's try to come up with this final compound. Right? Okay, this is our task. Right. So what we are supposed to do here? See, first of all, analyze the two compounds. Right? Here you are with 3 carbons, 3-carbon compound, and here you are with kind of 6-carbon compound. Anyway, kind of 6-carbon compound, but it is not just the carbon-carbon bonds are there. Not just the carbon-carbon things are connected. You can clearly see a polar bond, the carbon-nitrogen bond appearing, a polar bond appearing in your final compound. So that what you need to do, just break from the polar bond. Just break from the polar bond. Always just break from the polar bond, right? If you are seeing any kind of a polar bond is appearing, always break from that. Don't try to break from any other instance, any other from any other bond, right? So you can break from this bond as well as this bond, right? No worries, huh? මෙතනින් break කරත් කමක් නැහැ හොඳයි. ඒකත් NH තමයි. No worries. Both can be done, right? Okay. So break this thing and then put that smaller molecule to the two atoms. So at the nitrogen side, you have to write the H, and at the carbon's corner, you have to write the Br, the smaller molecule. Just put that thing there, right? Okay. I just broke the polar bond and put some hydrogen to the nitrogen side and put some Br to the carbon side. So actually this compound is made by the reaction of this alkyl halide and this amine. The reaction of this alkyl halide and this amine, you can come up with this total compound. So just write this thing: CH3, CH, CH3, just Br, right? Connecting with the NH2, NH2, CH2, CH2, CH3. Now this is the heart of the question, no? Actually, polar bond makings are very, very simple. Polar bond makings are very easy. Polar bond making questions are very easy, Lama. Why is that? Because with this working, right? You are just coming up with the two immediate compounds which will form the ultimate compound, right? When it comes to polar bond making, with this working, you are just coming up with the two immediate compounds which will give you the final product. It is not like the carbon-carbon bond making. In carbon-carbon bond making, after the working, you got some two compounds which should be connected from here as well as from here. Those two compounds that at the final, that compound should be converted to the final product, as well as that stuff should be connected to the initial compound as well. But here with the working, with the breaking and that working, you just get the two immediate compounds responsible for the product, right? So just reacting those two will give you the product. No need of further workings to convert the thing to the final product. So that is why I am saying the polar bond makings are very easy. Those are referred to as bonus questions if those are there in your A-level paper. In your A-level paper, if a polar bond making is there, polar compound is there to make, those are bonus questions actually, right? Okay, what we need to do here is just converting this stuff to here. So you have a 3 carbon compound. Here is also a 3 carbon compound. At the center carbon you have Br, right? At the center carbon you have Br, so that you can easily come up with that thing by just adding what HBr, Markovnikov. To the center carbon the Br goes, and to the corner carbon hydrogen goes, right? So with the center carbon the Br will be available then. Here at the corner carbon the NH2 is there, so you need to come up, first of all you need to come up with the anti-Markovnikov, right? So you need to come up with anti-Markovnikov, right, to give the functionality to the corner carbon, like this. There is anti-Markovnikov, so it is just the HBr adding with the R2O2 medium. So then you can complete the stuff by just adding some NH3 to your Br, right? So adding some NH3 will convert this Br to NH2, right now at the corner carbon. No worries, no? So this is how we are supposed to do the conversion. So basically the polar bond makings, I'm telling you again, the polar bond makings are very easy, right? Because you just get the immediate two compounds which will form your product by the working, by your working, right? Okay, right? This is all about forming the CN single bond, the CN single bond, right? Okay, let's do the next stuff. So you can take a screen capture here. Screen capture ගන්න ළමයි අවශ්‍ය දේවල් තියෙනවා නම් අපිට පස්සේ ඊළඟ බොන්ඩ් එකට යන්න. හරි ලේසි ළමයි පොඩි දෙයක් තියෙනවා. ඔයාලට අත්‍තරම මේක තියෙනවා මෙන්න මේක මතක තියාගන්න තියෙනවා. ඒක තමයි වැඩි. හරි. මේ පුංචි මොලිකියුල් එක මතක තියාගන්න තියෙනවා. මේක මිස් වුණොත් ඉවරයි හොඳේ. මේ මොලිකියුල් එක අමතක වුණොත් ඉවරයි. ඔය තරම කේස් එක හරි. මේ පැනල්ටි ටික තියෙනවා. මේ මොලිකියුල් එක මතක තියාගන්න වෙනවා. මේ මොලිකියුල් එක මතක තියාගත්තොත් හරිම ලේසි. පොඩි දෙයක් ඉතින් හරි. ඒවා කරන්න ඕනේ එකම දේ එච්චරයි. මේ චූටි මොලිකියුල් එක මතක තියාගන්න තියෙන්නේ. When you are forming the amine bond, it is the HBr or the HX, HBr or the HCl kind of thing, halogen, right? HXO kind of thing will release. So you need to remember this thing. That's all. Right? Right. Okay. Let's come up with the second kind of polar bond. See. Right. Number 2. Polar bond making number 2 is the amide bond. See this one. This bond. Right. This is referred to as the amide bond. Right. First discuss about how to produce the amide bond, the theory behind that thing, right? Producing an amide bond. So to produce an amide bond, first of all, you need to come up with the acid chloride. Acid chloride. I write like this, right? First you need to come up with the acid chloride. So acid chlorides should be reacted with primary or secondary amines. Acid chloride should be reacted with primary or secondary amines. See? So if this kind of thing happens, let's come up with this acid chloride. This kind of acid chloride, right? Acid chlorides are the ones which will produce when you add some PCl3 or PCl5 to the carboxylic acid, right? If you add some PCl3 or PCl5 to the carboxylic acids, you come up with this acid chlorides, right? So if this acid chloride is to react with some amine, it could be primary only with one R group, or it could be a secondary amine, right? So I'll write them both at once, right? It could be a secondary amine as well. Secondary amine means you are with only one hydrogen and two R groups are there with that nitrogen, right? Acid chloride, this is primary amine, secondary amine. You know what will happen? Like in the earlier case, this Cl will leave with one of these hydrogens. Yes, the Cl will leave with one of these hydrogens, and so that this carbon and nitrogen will connect, making the CN bond, C double bond O N bond, the amide bond. See, I'll just connect. So you have the CH3, C double bond O, that nitrogen will be connected here. You have this R and H, leaving this small HCl molecule. Yes, see, right? So CH3, CO, the Cl will leave with this hydrogen, and this nitrogen will connect to that carbon. This nitrogen will connect to that carbon, right? Leaving this HCl molecule, small HCl molecule, right? So these are referred to as amides. This is the amide bond, and these are referred to as amides. Right? This is how we are supposed to produce the amide bond, right? Produce the amide bond, right? Okay. This is the theory. This is the theory behind the situation, right? So let's discuss how to use this thing in a conversion. How to use this thing in a conversion. So how to think of the starting compounds by looking at the final compound. How to think of the starting compounds, how to guess the starting compounds by looking at the final compound. Let's discuss about that thing. So I'm always saying you, as in the earlier case, right? You are supposed to break the bond from here, from the polar bond, from the most polar bond. Just break, right? And then what you need to do here, you have to remember this small molecule, right? You have to remove this small molecule. So to the nitrogen side, just put the hydrogen. To the carbon side, just put the chlorine. Just put the chlorine. So you can make this compound by reacting CH3COCl with RNH2, right now. So in this case as well, just break the bond from the amide bond, put the hydrogen of the HCl here at this nitrogen side, put the chlorine at the carbon side. So if you have to react this acid chloride with this amine, R1R2NH, you will get, right, this compound, right now. So this is the theory, right, behind the formation of amide bonds, right now. Let's try to use these reactions of forming amides in conversions, right? Let's come up with an example conversion here, right? Let's do. Right, some example conversion. Right, okay. See, example conversion. Right, let's start with this one. Let's start with the same alkene, and let's try to come up with this compound. Right, Okay, let's try to do this conversion here. Right, you clearly see you are with a 3 carbon compound and some compound with larger number of carbons are appearing, and you clearly see this polar bond. So from that you need to break. When a polar bond is appearing, from that you need to break. That's it. No need of calculating the carbons and the stuff. If a polar bond is appearing, just break from that bond and put the hydrogen at the nitrogen side and put the chlorine at the carbon side. Then that will give you the 2 compounds responsible for making this larger compound, the amide. So here this is formed by this alkyl here, this acid chloride. See, CH3, CH2, COZL, that is the acid chloride, with this one, reacting this acid chloride with this NH2 stuff, right? You read these two guys, you will get this one. No need to add anything lama here. No need to add anything. Just read these two guys. You will get this amide, right? So this is the heart of the question, right? So the problem is solved actually now. So what we need to do is actually to connect these two things to here. So basically 3 carbon compound is there. Here also 3 carbon. Here as well as you have 3 carbons, right? So just simple connections, right? To be done, right? Sorry for that. Right. So let's make this one first. Let's try to make this one first, and then we can go with that, right? So to make this one, so you have a corner carbon as the functional carbon here. So first the functionality should be brought to the corner position. That can be done with the R2O2HBr. R2O2HBr will bring that function to the corner carbon. Then this is always coming through a carboxylic acid lamine. This is always coming through a carboxylic acid. Acid chlorides are always coming through carboxylic acids, right? To a carboxylic acid. If you are to add some, PCl 3O PCl5, this OH will be connected to Cl. That is how the acid chlorides are made. So basically, to come towards oxygenated compounds, first of all you need to come through alcohols. Right now, so these conversions could be carried out with use of NaOHAQ here, and with some H plus KMnO4 here. Right now, okay, let's do this one. Try to complete that thing, right? So what you do, first of all you have a center carbon as a functional carbon. So functional should be bring to the center. So this is a 3 carbon situation, center carbon as a functional carbon. So just bring the functional to center. That can be done by a Markovnikov addition of HBr or OH both, right? I'll just come up with the Markovnikov addition of HBr, because BRs need only one step to convert it to the NH2s, right? So just HBr and just one step will convert this into then NH2. Is adding NH3. Right now, this is your conversion. Right? That is the amide bond formation. Right? So are you clear? Do you have any questions? You can ask, right? Not hard ළමයි. ලොකු ඕලක් නැහැ නේද? හරි එකම දේ මොකද්ද කරේ? හැමතිස්සෙම polar bonds තියෙනවා නම් ඔය compound එක just break the compound from that polar bond. මෙතනින් break කරන්න යන්න එපා. මෙතන bonds දෙකක් break කරන්න යනවා. It is very hard to break such kind of situation, but it is very easy to break this one rather than breaking this, right? polar bonds දෙකක් තියෙනකොට polar bonds දෙකෙන් lazy එක break කරන්න. මේක break කරන්න lazy. කඩන්න දෙපැත්ත. හරි. ඊට පස්සේ you should remember this small molecule. එතකොට යාගේ negative polar molecule එකේ polar bond එකේ negative pole එකට ඔය small molecule එකේ positive pole එක දානවා. So the chlorine goes to the carbon, right? So you can come up with the immediate two compounds that will complete the process. හරිද? ඊගොම තමයි polar bond making වල amide bond එක හදාගන්න. This is polar bond type 3 imine bond, where you see this kind of a carbon nitrogen double bond. It's referred to as imine bond. Let's discuss how to make this one. So basically to make this imine bond, you are supposed to use kind of an aldehyde or a ketone. Aldehyde or a ketone should be used, right? Should be used with a primary amine. With a primary amine. Only the primary amines are available to make the CN double bond. Let's discuss why. Right? The theory part. So bond forming is done like this. So you can come up with a aldehyde or a ketone. See, you are with a aldehyde like this, or a ketone like this. I just had the aldehyde ketone in some different configuration, right? Okay, if you react these aldehydes or ketones, these are the aldehydes, the ketones. With the carbon, you have two R groups for the ketone. With this carbon section, you have a R group and a hydrogen, the aldehyde, right? If you react this one with a primary amine, primary means you need to have two hydrogens. You need to have two hydrogens. You need to have two hydrogens, right? Like this, primary amine, primary amine. Primary amine, two hydrogens are needed, definitely needed, right? To get rid of that smaller molecule, to connect the nitrogen and the carbon, we need two hydrogens. See, what is the smaller molecule here? Here, this oxygen will be removed with the two hydrogens of the nitrogen. So basically, to form a carbon nitrogen double bond, to form a double bond, basically two bonds, right, should be left, right? You should leave two bonds, right, to make a double bond. So two bonds, right, can be taken from here after leaving the oxygen, and two bonds are needed so that the nitrogen need to release two of its hydrogens. So primary amines are needed. With secondary amines you can't do so. With secondary amines only one hydrogen is available as two R groups are there. With tertiary amines you can't do so. Three R groups are there, no hydrogens are there. That means definitely two hydrogens should be there to do the process like this, to connect the carbon and nitrogen via a double bond. So see the stuff. So this oxygen will leave with the two hydrogens from here. So you will end up with the CH3, the hydrogen is there, and the double bond will be created between the nitrogen and carbon. Star is there. So this H2O, the small molecule H2O will leave. Right? In this case as well, this oxygen will leave with the two hydrogens of the nitrogen. So the carbon and the nitrogen will connect via a double bond. So this is how the imines are formed. These are called as imines. When the carbon and double bond is appearing with your organic compound, those are referred to as imines. Right? Okay. That is the theory. These are two reactions responsible for forming imines. Right? Let's discuss how these reactions are used in conversions. This is about that thing, how these things are used in conversions. Right? How to predict the two compounds which are responsible to make these imines. Let's discuss about that. How to predict the two compounds by seeing this imine. The two compounds which produce that imine. Right? So what you need to do is just break the compound from the polar bond. Just break the compound from the polar bond. Here it is the carbon nitrogen double bond. There is only polar bond available now. Just break the compound from the polar bond. Right? Then towards the nitrogen side, just put two hydrogens of H2O. To the carbon side, just put the oxygen. The H2O is your small molecule in this case, H2O. So that if you react this aldehyde COR, so it's like CH3 CHO, that aldehyde with this primary amine, right, the RNH2, you will get this compound. In here as well, first break the polar bond and connect the two hydrogens to the nitrogen and connect the oxygen to the carbon in your H2O molecule, so that this ketone will react with this primary amine, right, to give you this compound by leaving a H2O molecule, right? Now, so that is the idea, right? Okay, so you are clear now. Now let's use this. These reactions of forming imine bonds to do a conversion, right? To do a conversion. Let's use this one. See this conversion. Let's start with the same alkene, see this stuff. Right. Okay, you're supposed to convert this starting compound to this one, right? Let's do this conversion, right? So what we are supposed to do? So just these 3 carbons, no worries, right? So you are with some compound with greater number of carbons. Anyway, it's a polar compound. It's a polar compound. So it is a compound with polar bonds, right? Polar bonds, carbon, nitrogen, carbon, oxygen bonds. So carbon, nitrogen bonds are there. So it's a compound with polar bonds. So just break from there to come up with the 2 immediate compounds which are responsible for making this large compound. Break from that polar bond, the CN double bond, the imine bond, and put those 2 hydrogens at the nitrogen side and that oxygen at the carbon side, right? Then you will get the 2 compounds which are responsible to make this imine bond. So this is actually a ketone, CH3CO CH3. You can write like this as well, no worries. This is your ketone, CH3 CO CH3, CH3 CO CH3, right? Then this one is CH3 CH2 CH2 NH2. No? So you have the NH2 with CH2 CH2 CH3. If you react these 2 guys, definitely those will give you this final compound, right? So that is your heart of the question, right? Right. So your next task is to complete forming these 2 guys. So you have a carbon at the center. These are very easy stuff, Ramaya. You have a carbon at the center, an oxygenated compound. So should go to alcohols, right? So carbon at the center means Marconic of addition. So just like this. Just PCC, and to put some OH, just the NOH. To form this one, you need a functionally at the corner carbon. So antimony should be done. Antimony should be done. So antimony should be can be done only with the use of HBRs. So HBr2O2 should be added. Then only a single step, no? So BRs can be converted to NH2s simply by adding some NH3. Simply by adding some NH3, no? Simple as that. So conversions are very easy when some polar compounds are appearing. Polar compounds with those polar bonds, CN single, CN double, amide bond, ester bond, even the ether bond, CO single, right? So that is the example conversion for the imine bond. Very easy stuff, huh? Actually, what you need to remember is this smaller molecule. පොඩි එක්කෙනෙකුට මතක තියාගන්න පුළුවන් නම් එච්චරම තියෙන්නේ. වෙන කිසි දෙයක් නැහැ. එයාව ඉතින් මිස්සුනොත් ඉවරයි මොකද? එයාව මතකුනොත් ඉවරයි මොකද? කරන්න දෙයක් නැහැ. එහෙම ලොකු දේවල් නැහැ නේද සාමාන්‍ය H2O, HBr ඒ වගේ පොඩි මොලිකියුල්ස් ටිකක් තියෙන්නේ. HX type එකක් H2O. ඊළඟට කතා කරන්නේ NABr තියෙන පොඩ්ඩක්. පොඩි මොලිකියුල්ස් ටික පොඩ්ඩක් අර ඒක පොඩ්ඩක් ලියලා තියාගන්න පුළුවන් නේ එච්චරයි. The 4th kind of polar bond, right? හතරවෙනි polar bond එක. That is the ether bond. Let's discuss about how to make an ether bond. right, when forming organic compounds with some large number of carbons, right? The ether bond formation. Right, number 4, the ether bond, that means CO bond. Ether bond, right? The CO bond. So one can say COCl and මොකක්ද කියන්නේ COCl කවන්නේ right? COC. Or the CO single bond, that's it. CO single bond. CO single bond එකේ කොට alcohol කියලා දෙන්න පුළුවන් ඒකයි මේ දාලා තියෙන්නේ. ether bond හරි. Ether bond. To prepare an ether bond, basically you need to react some sodium alkoxide with alkyl halide, right? React some sodium alkoxide with alkyl halide. Let's discuss what these sodium alkoxides are. A new name, alkoxides, right? Let's see what they are. So we can come up with alcohol. We can think of alcohol, no? It's alcohol, no? So if you add some sodium, as alcohol showing some acidity, it will produce a salt. Right? So as this one showing some acidity, the OH bond and the already there, so H plus can be released, right? With this kind of a active metal, right? Basically, if kind of acid is to react with the metal, you get the salt and H2, no? That is what happens here. You have a alcohol getting with a sodium, so you will produce the salt. This is the salt. If you are to react the sodium with the HCl, if you react the sodium with the HCl, what you will produce is NaCl. If it is HCl, you produce the salt in the form of NaCl. NaCl is a salt, while the H2 will be released. So if you do the same with this one, it is going to be Na this thing, CH2CO minus Na plus, and H2 will release. That thing is referred to as the sodium alkoxide. This is referred to as the sodium alkoxide. This is the alcohol, no? So from the alcohols you create the sodium alkoxides. So name, don't worry about the name, don't worry about the name here. So it's like this, no? This is sodium hydroxide. Mean what is sodium hydroxide? This is known as the hydrogen oxide. Hydroxide. Hydrogen oxide is the hydroxide. And then this one. This one. So you have the alkyl section here. Any kind of R section. So sodium alkyl oxide. Alkoxide. Here this is the hydrogen oxide. Hydroxide. Alkyl oxide. Alkoxide. That's it. There's nothing to worry about. Sodium hydroxide. Sodium alkoxide. Alkyl oxide. Hydrogen oxide. Same, right? Sodium alkoxide. So if you react the sodium alkoxide, right, with alkyl halide, like this, any kind of alkyl halide, right? What happens is actually, right, this sodium and Br, these guys will leave, connect in the carbon and the oxygen. Connect in the carbon and the oxygen. These two guys will leave. So you will produce a carbon oxygen bond by this reaction. CH3 CH2 oxygen. This is a new bond formed. CH3. You will leave the NaBr molecule. Sodium will leave from here. The Br will leave from the alkyl halide. So this is referred to as a ether. This is referred to as a ether. This is referred to as a ether. Ether again no cut. Those are ethers, right? So that is how the ethers are produced. First you need to come up with the sodium hydroxide. Then you have to react that thing with the alkyl halide. So that a small molecule, that is NaBr, will leave, while the R group from the alkyl halide will connect with the oxygen of the sodium hydroxide. Right? Okay. So this is the idea. So let's examine how you are supposed to come up with the starting compounds by seeing this one. That's what we have doing now throughout this session, right? So we should be able to come up with the starting compounds by just seeing the ether now, right? How to read that thing? It's like this. First break from the polar bond. First break the ether from the polar bond and put the Na plus or the positive part of the NaBr, send that to the negative pole of the bond, and the negative part section of the NaBr, send that to the positive pole of the bond, so that you could predict the two compounds which are responsible to give you the ether. That is the CH3 CH2O minus Na plus, the sodium hydroxide, and the CH3Br alkyl halide. Right now, that is the idea. Right. Let's use this thing for a good conversion. Let's use this one for a good conversion. Right? Okay. Example conversion. Right, see, you are supposed to start with this alkene and supposed to produce, see, this kind of stuff. Right? So that is what you are supposed to come up with by just starting with this on the organic compound. Right? Okay. Let's do the stuff. Right. See. First of all, let's count this one. 3 carbons. And then when it comes to this side, you clearly see some polar compound is there. So polar bonds are available. CO bonds, CN bonds, like those are the polar bonds. Those are available. So break from those bonds. Here see break from this bond, CO bond. So here you are with 2 CO bonds. You can break from any one of those. You can break from here as well as here. No worries, no worries. මෙතරින් break කරන්න පුළුවන්. නැත්නම් මෙහෙන් break කරලා ගන්න පුළුවන්. No worries. කොහොමත් same thing. So put the Na plus or the sodium with the oxygen terminal and put the Br with the carbons terminal. Then you will come up with the 2 immediate compounds responsible for making this ether bond. So that is the CH2CH2 CH2Br, that alkyl halide, and the other thing is this one, some alkoxide. The other compound is some alkoxide, the sodium alkoxide, where oxygen is connected to the center carbon. The oxygen is connected to the center carbon. So we can write like this: CH3, the center carbon, you have a H and a ONA, and to that another CH3 is connected. Right now? CH3, CH, CH3, and with that center carbon you have a O minus Na plus, O minus Na plus. Right now? Okay, let's complete the stuff. Before doing that stuff, right, this is actually right. So before thinking of any, first write this one. So always the alkoxides are formed by adding some sodium to the alcohols. Just write that thing first of all. Adding some sodium to your alcohols. That is how the alkoxides are formed, right? Now complete the stuff. So you have a Br at the corner carbon. So anti-monomer should be done. Br at the corner carbon, anti-monomer should be done. Function to the corner carbon. So R2O2 HBr. And here some OH at the center carbon. OH at the center carbon. So Marconic addition. This is the Marconic addition of H2 molecule. So you can come up with the Dil H2SO4. Right now? That's it. Very simple conversations, huh? The Polor bond makings are very simple. Not that much hard. Right now? Okay. You can complete stuff, right? After that, we'll leave for the. We'll go towards the fifth kind of Polor bond, right? This is done, no? No worries, no? මෙතන ළමයි ඕනනම් bond එක මෙතනින් break කරන්න පුළුවන්, right? You can break from here, and if you are to break from here, still the oxygen terminal carry the sodium, and the carbon terminal, this terminal will carry the Br, the alkyl halide. Right? Okay. Right. Let's discuss about the fifth type of compound under the Polor bond makings. Right? That is all about the esters. Let's see. The ester bond. Right? The fifth kind. Right? If you are with this kind of a bond in your final compound, those compounds are referred to as esters, and this bond is referred to as the ester bond. Ester bond. Ester bond. So to make the ester bond, two methods are available. Right? Two methods. So you can use kind of a carboxylic acid. Or an acid chloride or an acid chloride. Actually with a alcohol. So if an alcohol is used with a carboxylic acid or acid chloride, you can come up with a ester or the ester bond. Right? Let's discuss about the theory behind this thing. It's like this. So if you are to add this carboxylic acid to your alcohol, right? See this alcohol. You know what will happen? Then OH from this thing will leave with one of the hydrogens from here, and then this carbon will connect to this oxygen. Giving you this by leaving that smaller molecule H2O. Right? Actually, to do this process with the use of a carboxylic acid, if you are supposed to create this ester, to do this process, you need to add a catalyst. That is the concentrated H2SO4. Right? The concentrated H2SO4 catalyst is highly needed with some heat, highly needed to create this ester if you are to react this carboxylic acid with alcohol. If you are reacting a carboxylic acid with alcohol, if you are reacting a carboxylic acid, then it is very essential to come up with the conc H2SO4 catalyst. Right? To form the ester. But if you are going with the acid chloride, to make your ester with your alcohol, if you are going with the acid chloride with your alcohol, like this, then even without the use of a catalyst, this Cl and one of the H from here will leave. Even without a catalyst, no need of catalyst to form the ester from acid chloride. To form ester, no need of catalyst, right? That Cl and H leaves, and then the carbon and the oxygen will connect. After these two guys leave, this carbon and this oxygen will connect, right? So these are the esters. And these are referred to as the ester bond. Right? There are two methods with the use of a carboxylic acid as well as acid chloride. You can create esters. But the important thing to note that is actually with the use of carboxylic acid, you need a catalyst. With the use of acid chloride, no need of catalyst. Right? So both the pathways are with positives and negatives. When it comes to this pathway, when it comes to carboxylic alcohol pathway, right? You can do the conversion with one less number of steps. Right? But if you are to do the conversion through the acid chloride, basically, first you need to come up with the carboxylic acid, then you need to convert that into acid chloride. After coming up with the carboxylic acid, you need to convert that into acid chloride with the use of PCl3 or PCl5. So if you are going through the acid chloride pathway, basically one more step is used compared to the carboxylate pathway, right? That is one negative thing with the second pathway. But no need of a catalyst then. No need of a catalyst then, right? That is the two differences between the two pathways. So in your region box, if the PCl5 is not given and the conc sulfuric is given, then you need to go through this pathway of producing ester. And in your region box, if the conc sulfuric is not given and the PCl5 is given, then you need to go to the second pathway, right? That is how we are supposed to come up with the correct pathway of producing the esters. If the conc sulfuric is given and the PCl5 is not given, then use this pathway to form your ester. But if the conc sulfuric is not given and the PCl5 is given, then after producing the carboxylic acid, then follow this pathway to produce your ester, right? That is the usage of these two pathways, right? Let's see how these are supposed to use here. How to predict the two compounds here, right? How to predict the two compounds. It's like this. So ester can be broken from this bond, the ester bond, and to this side you are supposed to add some hydrogen, and to this side some OH. No, there is one way of breaking the ester bond, and the other way is to the oxygen side just add the hydrogen, and to the carbon side just adding a Cl. Those are the two methods available to break the ester bond to come up with the immediate two compounds responsible to make the ester, right? Okay, let's do an example conversion to complete the note, right? Conversion. Let's do one example conversion for this one as well, right? Some example conversion. Right. See, let's say they have given you this kind of stuff, and they have, sorry, I'll write it here. They have given you this kind of a thing and ask you to create this one. See how to solve this kind of question, right? Let's see. So you are starting with 3 carbon compound, no worries. And when you are looking at this one, you clearly see this polar bond, ester bond appearing there. So you have to break from that ester bond. So this is the bond to break, right? So to the oxygen side, you can add the hydrogen. To the oxygen side, you can add the hydrogen. To the carbon side, you can add the chlorine or the OH. Both are available. Na? To the carbon side, OH or the chlorine, both are available. So let's come up with the chlorine form. No worries. Let's do the thing with the H2 form. H2 form, right? That's better. So for the H2 form, remember you need to come up with the catalyst, right? Let's write with that form. No worries, right? Both forms are available. I'll come up with the H2O form, right? So let's see. So that this is formed by reacting this alcohol with this causes it. This causes it. Right? As I am going with the causes it, I need to add the catalyst, right? Conquistous catalyst is needed as I am going through the causes it. Right? Now let's complete the stuff, right? Here this is very easy. You have the OH functionality at the center carbon, OH functionality at the center carbon. So just the Marconic addition. Just the Marconic addition. So you can come up with the DH2SO4 here. To come up with this one, you need the functionality at the corner carbon. So that the anti-magnetic thing should be done first of all. So anti-magnetic thing can be done only with the HBr, right? HBr-R2O2. So first you will create this kind of stuff. Then to come towards the oxygenated compounds, first you need to convert the compounds into the alcohols. To come towards the oxygenated compound, first you need to convert to the alcohols. That can be done with the NaOH. Then the alcohol with the corner carbon functionality can be converted easily towards a carboxylic. As is the primary alcohol, you can convert that thing easily towards the carboxylic with the same R group, right? So just the H plus came in a 4. Or one can say one can come up with the dichromate as well, right? So that is the simple conversion, right now. So that is the example conversion for forming esters, right? Forming esters. So you can break this thing as a H2O molecule or a HCl molecule. If you are going through the H2O form, you need to add the catalyst. But if you are going through the HCl form, no need of catalyst, right? That is the difference between the two things here, right now. Okay, right. So you can have a screen capture here. Right now. Okay, so that is all. This is all about today's lesson. We have just completed the polar bond makings, right? We have done much work today, right? So study those things and come to the next class, right? We'll do some exercises there, right now. So let's wind up at this stage, right? So until the next week, goodbye then.